Okay, so yes, as Matthias mentioned, I'll be sharing with you how we can detect Megacart and other malicious scripts with our new WebOrion JavaScript malware detection engine, right? And I think okay, and Matthias has introduced me just now. Thank you. I'm Kyle. So I'm a senior software engineer. I work on the WebOrion Defacement Monitor as well as our other WebOrion products. Right. So yeah, there's this picture here. So I think Matthias earlier showed you, right, some types of defacements. These type of defacements are visually visible. You can when you see the page, you know that something has changed. But not all defacements are like that, right? So sometimes I feel that certain kind of so sometimes hackers, when they want to change the page, they will change it in such a way that it is hidden. Like just like they try to hide among your legitimate content to try to do a malicious task instead of what do you call that? They want to do something malicious rather than just make a statement that I managed to hack your site, right? So they try to stay hidden. So it's like a bit like this. This picture shows a game called Among Us. We're trying to find out among this group of players who is the one who is trying to sabotage the whole game, right? So this brings me to what I want to talk about today, which is the kind of threats we're talking about, right? Which are malicious scripts, right? So such scripts are what we call a hidden threat, right? You don't see them when you just visit the page, right? They are running in the background of the page, like the scripts. So some examples of these are like card skimming scripts, cryptojacking scripts, right? And then after that, I'll talk about our WebOrion JavaScript malware detection engine. Right. So first, let me show you this picture. Right? Do you observe anything wrong with this ATM in this picture? Anything? Anybody notice anything? Right, I give you a few seconds to look at it. So actually, what's with this ATM is that it's actually a ATM trying to do a card skimming attack, right? So card skimming basically is like the attacker is trying to it's called skimming because they're trying to make a copy. When you insert your card, they scan the magnetic stripe right on the back of the card, and they try to make a copy of the card. And then they also have this fake pin pad that they put on top of the actual one that when you type in your pin number, they capture, right? So with this, they can capture your pin number, they can make a copy of your ATM card, and then they can go and try to duplicate your ATM card and withdraw money from your account, right? So this kind of thing has happened before. It's more common overseas than Singapore, thankfully. But it's what we call real-world card skimming, right? And of course, when we go online, card skimming also has moved online, right? Which is the rise of e-commerce. Card skimming on the web means you try to steal credit card information. Okay. So we have seen increase in attacks in recent years, right, of such things. So you may have heard some high-profile cases before. British Airways, New 8, Ticketmaster, right? These are some companies that have encountered this kind of card skimming attacks on their websites before, right? And even just last year, 5th of October, you can see here, there was this case where there's this US mobile operator. It was found that there was this card skimming script on their website, on their checkout page, right? And a lot of people are working from home also, so there's this virtual conferencing platform where they allow people to sell online conferences. They've also compromised with this card skimming script, right? And this is of course a big problem, right? What happens is that when you have a card skimming attack on your website, it means that anybody who type in the card number on their on your website, the information actually gets stolen by the attacker, right? And the hacker can do whatever they want with it, right? So that's a concern. And if you ever wonder why is it called a Megacart, which is like the title of this talk, Megacart comes from the references this e-commerce platform called Magento, right? That is used by a lot of e-commerce sites. It's an open source platform. So all the attacks against the shopping cart on this Magento platform, they call it Megacart attacks, right? Oh, and of course, yeah, this is a compromise of payment data, which is a concern to both the users as well as the company, right? So the next type of threat I want to talk about is actually cryptojacking, right? In summary, this is really just essentially illegal cryptocurrency mining, right? So how this works is that if you're not familiar with how mining works in cryptocurrency context, right, is that in a cryptocurrency world, right, unlike our normal currencies, they don't have a central authority to verify transactions, right? So the way they solve this problem of how do you know the transaction is the correct one is that they use a lot of computing power to verify this transaction, right? And to incentivize people to contribute their computing power, they actually have this scheme where you actually get paid a small amount of this cryptocurrency if you actually help to provide this computing power, right? So that's what they call mining, right? That's why it's like mining. I contribute my computing power and then I get a small amount of this currency for myself, right? So in cryptojacking, what happens is that the hackers don't want to use their own money because you want to run all this computing power, you need buy the hardware, you need electricity. So the hackers, of course, if I can use other people's computing power, why should I want to do this myself, right? So they actually hijack people's computers to do this mining for them, right? That's why it's called cryptojacking. So here's one imaginary, what's that? Like cryptocurrency mining scenario, right? Let me move this away. If you actually, okay, so this is an example of my AWS bill, right? So you see $7.80, right? But imagine if you wake up tomorrow and then suddenly you see, oh, it's $78,000, right? So it's like, what happened? And okay, this may seem hypothetical, but it actually happened to Tesla in 2018, right? So what happened was that hackers actually hacked into Tesla's cloud infrastructure, and they managed to turn on a lot of like new cloud infrastructure, new servers to mine cryptocurrency for the hacker. So this is one way the hackers try to do cryptojacking to illegally like earn cryptocurrency for themselves. And other than cloud infrastructure, what we are concerned with, especially with web defacement, is this concept called browser-based cryptojacking, right? So it was reported actually last year that browser-based cryptojacking had increased by 163% after a time of like dropping, and this was based on a Q2 2020 Symantec threat landscape update, right? You can see the code here. And that was an increase in resurgence after, which due to the spike of the value of extreme currencies, which they say here, Bitcoin and Monero. So how do these malicious scripts work? Right. Let me try to explain here. So for all this, what's it like a script? They use JavaScript, right, which is a programming language which is available in all web browsers. So many websites nowadays use this, or rather, I say most websites nowadays use this programming language to do all the fancy dynamic links that we can see on the site. Right? And in the case of this browser-based card skimming attacks that I mentioned earlier, right, what happens is that the hacker, just like other defacement, they find a way to gain access to the website and modify the web page content, right? And then they, with the access to the website, they somehow can modify the page. They put in this script, and this script is hidden, in the sense that it's visible, in the HTML, but when the user visits the site, they don't see any change to the page at all. And what does the script do is that when users load the website and then they try to fill in the form, the script will actually copy the data and send it over to the attacker server, right? So now the hacker has a copy of all these user credit card data that they have entered, all the card number, expiry date, CVV. What can they do? They can go and use to buy expensive items. They can go and sell it to other hackers, on those dark web forums and that kind of thing, right? And of course, financial information is compromised. So in the case of the browser-based cryptojacking attacks, right? So in this scenario, again, the hacker finds a way to gain access to the website and they modify the page content. And again, they put in the hidden script, right? But unlike the card skimming, the hidden script here, the purpose is not to steal the credit card data, but instead to mine cryptocurrency, right? So in this case, when the users visit the website, right, there's this script on the page. As long as the web page is open, the script will be running and using the user's CPU, computer CPU, right, to go and mine cryptocurrency. So the user will suddenly find, oh, their laptop, but maybe the fans start to spin up very loud because the computer is working very hard. And even though your page might be very simple, in the background, with this script, the page is working very hard to mine cryptocurrency. Right, so this does not sound so malicious. And of course, all this cryptocurrency all end up going to the hacker, right, and not to the website owner or not to the user at all. Right, that's why it's considered malicious. Right, and of course, if users see this, notice that there's this script on your website, it's quite bad for the site's reputation, right? That somebody has managed to actually inject this cryptojacking script onto the site itself. So with all these threats in mind, right, we have this engine called JavaScript malware detection engine, which want to try to detect all this. And the way the engine works is quite simple. We have, on your website nowadays, you probably have a lot of JavaScript. We actually take all the scripts that we can find on the site, and then we feed them through scanners that check the scripts against signatures of known malicious JavaScript. Right, so we have this set of signatures of known malicious scripts, and then it checks whether are these okay or are these considered malicious. Right, so now let me show you a demo. Need to switch my screen over. That. Okay, so this is our portal, as you may have seen earlier. Matthias has shown you, right? And we also have this demo site, salesdemo3.slbc.com, which is the same site that you might have seen earlier. Right, so let me make sure it's reset. So as you can see, this web page, this demo website already added to our portal. And if we try to verify the site, right, just like Matthias showed you earlier, you can see that it will take a while. But the status is okay, right? So that means there's nothing detected. So now I want to trigger the defacement scenario that we have here. In this case, we want to put in a coin miner script into the page, right, which is this scenario. And now let me refresh the page. So if you see this page here, do you notice anything different? Oops. So actually, this is a silly question because there's no visible change on this page, right? As I mentioned, the cryptojacking scripts are usually hidden on the page. They don't want to alert the user that they are trying to do the mining in the background. So there's no visible change. And if I try to manually verify again, just to force it to verify rather than waiting for the next time it checks this page, you can see, oh, okay, we have detected some things. Right, so we haven't turned on the new JavaScript malware engine yet, but you can see that there are some detections, which that there's a new script and this kind of thing. So let's try to verify again and trigger an incident without this JavaScript malware detection engine. It's taking a while. Let's see if it does complete. Okay, it does. So you can see that here, you can see that there is one new script detected, right, and 8 new HTML lines detected. But this is not so, it's not so obvious what has changed, right? So without the JavaScript malware engine, right, what your team will have to do probably is you go and look at the incident itself, right? And then perhaps they have to do some analysis, they do the comparison. And then they come here and then they look at it and they try to find what's the change, and then they notice, okay, there is actually a change here. So what is this script? They have to read the script and then see, okay, so this one looks like a crypto mining script from a company called CoinHive, right? So this is what they will have to do. So I think, this one is like, we can do better, right? We can make it easier to, if we know that the script is bad, we can make it easier for the analysts or the SOC operators to know that this is malicious, right? So if you have we can try to enable the JavaScript malware detection engine now, right? So this is the page, and you just like what Matthias showed you earlier, you can just click this button to start the free trial. So let's enable it. And now let's enable the JavaScript malware detection engine, and let's try to check it again. So again, this is trying to pull down the whole website and trying to scan all the scripts, as well as taking screenshots and other actions, right? So it's going to take a bit of time. Okay, so we have the results here. Okay, you can see that there is now, if you look at this, we have the 2 changes detected earlier, and we have the 1 script and JavaScript malware detection engine actually highlight to me that there's 1 script that is suspicious, right? Which is, in this case, this is what we call inline JS2. So this is the 2nd script on the page, and then it is identified that it's a Bitcoin miner. I mean, it's not exactly a Bitcoin miner, but it's some sort of cryptocurrency miner, right? But that's the code name that the anti-malware industry, they give to such kinds of scripts, right? And you can see all the other scripts on the page. It has checked them and no threat was found for them, right? So in this way, it's very fast, unlike using the content and analytics, you don't have to go and try to figure out what was the change and analyze it. If it's a threat, immediately it's a threat and you can take action much more quickly, right? So that's my demo of our JavaScript malware detection engine. Right, so let me go back to the slides. So I think you have seen all this earlier. Right, so with the JavaScript malware detection engine, I think this is a benefit that I mentioned earlier, is the engine alerts you if the JavaScript is known to be malicious. You can prioritize to respond to such alerts and put these alerts as higher priority, greater importance. It can respond faster, right? Because it immediately tells you that, we have found a malicious script. The other benefit that we think this engine actually brings is that, our other engines, especially the content and integrity engine and the image engine, these engines actually have the concept of a baseline, right? So we actually capture the page when it was added, and then we always compare against how it was like when the page was added, right? So this one works well if the page doesn't change very often, but there are some sites that are very dynamic. Perhaps like, it's a news page or the homepage of some e-commerce platform where they're always advertising their latest products or something like that. So in some cases, maybe the baseline is not so clear, right? With the JavaScript malware detection engine, because we check against a known list of bad script signatures, right, malicious signatures, you don't have to capture this baseline, right? It always checks against these known malicious script signatures. Right, as you saw earlier, to enable it, it's just a checkbox. You just tick the checkbox, and then you can enable it. So there's less configuration, and because of this, it actually will work with more types of web pages, right? And it can tell you whenever there is a JavaScript malware on the page itself. Okay, so how do you try out new engines? I think you've heard earlier from Matthias. I've seen my demo. It's very easy. We have the WebOrion portal, x.weborion.io. That's our WebOrion portal now, the one that Matthias and what I have shown you earlier. Right, if you actually are still using our old portal, please try out our new portal, because the new features, you can only find it there. And from the portal, as you saw earlier from the demo that I've shown, as well as Matthias, you can just start the free trial right in the portal. Or if you want to know more, or you want to have some customized requirements, you can contact our sales team. And just to let you know that our existing monitoring engines, if you're already using our monitor, will not be affected. Right. So we have shared with you earlier the NLP deep learning engine, as well as the JavaScript malware detection engine. These are engines in addition to the content and integrity and image engine that you're probably using right now. Right. So those engines will not be affected, and these ones will just give you additional things to and like additional detections. Right. So that's the end of my presentation. Thank you for your attention. And with that, if you have any questions, if you you can post them in the Q&A box on the Zoom, and then we can answer them.